Hello. In this lesson, we will cover one of the most useful topics in Linux and in DevOps work in general. We will understand where a command sends normal output, where it sends errors, how to redirect output into a file, how to pass the result of one command to another, and how to process text quickly with simple filters. So today, we're learning not just how to run commands, but how to build convenient working command chains. Let's start with the basics, because without them, everything later will look like a set of strange symbols. Any normal program in Linux has three standard streams. The first one is stdin. This means standard input. In simple words, it is where the program gets data from. Most often, this is the keyboard. The second one is stdout. This means standard output. In other words, it is the normal result of a command. For example, if you run ls home and the command shows a list of files, that is stdout. The third one is stderr. This means standard error. If a command cannot do something, the error message usually goes there. And here it is important to understand one simple thing. Normal output and errors may look the same on the screen, but for Linux, they are different streams. For example, if I type ls/home, I get normal output. But if I type ls and some wrong directory, I get an error. On the screen, it is all just text. But inside the system, normal output and errors go through different channels. That is why we can save output separately, save errors separately, combine them, and pass them on. So streams are the foundation. And the next step is to learn how to control them. When a command prints something on the screen, we can choose not to show it on the screen and send it into a file instead. The simplest option is symbol greater than. For example, now we have empty directory. Echo, hello, greater than file txt. This means take the word hello and write it into the file txt. If the file doesn't exist yet, it will be created. If the file already exists, its content will be overwritten. This is important. Greater than overwrite the file. And now we have this file and hello. If you do not want to overwrite it, but want to add text to the end, you use double greater than. I show echo world double greater than and same file. Now the line will be added to the end of the file. I show cut file. Yes. The logic is simple. Symbol greater than means right from the beginning. Symbol double greater than means append. Now let's talk about errors. If a command gives an error, normal symbol greater than will not catch it because it works with stdout, not with stderr. For errors, we use 2 greater than. I show ls some wrong directory 2 greater than and files errors txt. Now the error message will go into the file errors.txt. Let's check. Yes, we have this message. This is useful when you do not want to mix normal output with errors. For example, one file can be used for normal output and another one for errors. So stdout can go into one file, stderr into another one. And this already looks very close to real practical work. But it gets even more interesting when the result of one command is not written into a file, but passed directly to another command. It lets you take stdout from one command and pass it as input to another command. For example, let's etc grep ssh. What is happening here? First, ls etc prints a list of files. Then this result is not just shown on the screen, but passed to the grep command, and grep searches for lines that contain SSH. This is one of the most important ideas in Linux. One command does one job. The next command takes its result and does another job. That is how simple commands become a chain. So a pipe is a way to say, do not just show me the full result, pass it directly to the next step. But sometimes you want to see the output on the screen and save it into a file at the same time. For this, there is the t command. For example, ls etc and t result txt. Now the output will go to two places at once, to the screen you see and to the file result. Let's check. You see. If you do not want to overwrite the file but want to append, you can use t-a. T is very useful in long command chains when you want to see an intermediate result and save it at the same time. So the pipe passes data alone, and T helps you both see it and save it. But there is one more common task. Sometimes you do not need the output or the errors at all, and then you can send them into a special place where everything simply disappears. In Linux, there is a special path /dev/null. This is a special device that simply throws away everything sent to it. If you do not want to see normal output from a command, you can do this. Some command greater than /dev/null. If you do not want to see errors, use this command to greater than /dev/null. For example, if a command may complain, but those errors are not important for you right now, you can just hide them. And now one more important form. Two $1. This means send the error stream to the same place where normal output is already going. For example, how it used some command greater than all txt 2 greater than ampersand 1. What does this mean? First, normal output goes into the file all.txt. Then errors go there too. So both stdout and stderr will end up in the same file. This is a very common construction, especially in scripts, logs, and automation. And now we already have a good base. We understand that a command has streams. We know how to send output into a file. We know how to pass it on. And we know how to hide unnecessary output. The next step is to learn how to filter text quickly. The most well-known tool for searching in text is grep. To put it simply, grep searches for lines by pattern. For example, cat log txt grep error. This means show only the lines that contain the word error. You can search without case sensitivity. Grep -i error. The -i option means ignore case. You can also search the other way, which means excluding lines. Grep -v error. The -v option means show everything except the lines with error. Let's talk about basic regex, which means regular expressions at the simplest level. For example, grep log. A dot means any one character. Another example, grep error. This symbol means the start of a line. So this finds lines that begin with the word error. And one more. This symbol means the end of the line. So this finds lines that end with error. At the beginning level, it is enough to understand this. Grep searches not only for an exact word, but also for a pattern. And in real work, grep is used all time. Searching for errors and logs, searching for a needing line in a config file, filtering large output before the next command. So grep help us pull out the lines we need. And after that, we often want to sort them, count them, or group them. After we filter lines, we often want to understand what appears most often, how many lines there are in total, which values are repeated. For that, people usually use sort, uniq, and vc. The sort command sorts lines. For example, names txt sort. After this, the lines will be sorted alphabetically. The uniq command removes neighboring duplicates. And here the word neighboring is important. That is why people very often run sort first and then uniq. For example, cat names txt sort and uniq. Now the same lines will be next to each other first. And uniq will be able to remove duplicates. If you want not only to remove duplicates, but also count how many times each line appears, use uniq -c. For example, -c. Now we will see the count for each repeated line. And if you just want to count the number of lines, there is vc -l. For example, cut log txt grep error and we see this is how we quickly count how many lines with errors are in file. So now we already have a useful chain. Find needed lines, sort them, group them, count them. But sometimes we do not need whole lines, only separate parts of text. For example, one column or a set of characters. The cut command is used when you want to cut out part of a line. For example, you may have a file where fields are separated by a colon. A very common example is /etc/passwd. If we want to take only the first column, we can write cut -d -f1 etc passwd. The -d option means delimiter. Here, delimiter is this. The -f option means field. One means take the first field. Let's try. Everything. This is how you can quickly get, for example, a list of usernames. Now the tr command. It is used to replace or delete individual characters. For example, echo, hello, tr, h. Here, the small h will be replaced with a capital H. You see. Another example, echo. 1, 2, 3. tr and /n. Here, spaces will be replaced with line breaks. So each word will be on the new line. The tr command is especially useful when you want to clean text quickly, replace characters, or split a line into parts. The logic is this. Cut works with fields and positions. tr works with individual characters. But sometimes the next already looks like a table. And then it is more convenient to work with columns instead of characters. AWK is a very powerful tool, but at the start it is enough to understand its most practical part. It works very well with columns. Let's imagine that a command prints several columns separated by space. For example, ls-l. ls-l. If we want to print only the file name, we can use awk. awk Okay. And print 9. Here, 9 means the ninth field. So AWVK takes the ninth column from each line and prints it. Yes. One more simple example. Let's say we have a file called users.txt and each line in it has two fields. For example, Alice DevOps, Bob Linux. If we want to print only the first column, we can use cat users.txt awk and print 1. And if we need the second column, we can use print 2 or 3. So AWK is very useful when you have table like output and want to quickly extract specific columns. For a start, this is already enough. 1 is the first field, 2 is the second, and so on. And now there is only one more useful tool left, for when we do not need to search or cut text, but simply replace it. Set is often used for simple text replacement. The clearest example is this. Echo hello world set and s world Linux. Here s means substitute, which means replace. World is what we search for. Linux is what we replace it with. The result will be hello Linux. If you want to replace all occurrences in the line and G at the end. Set is convenient when you want to quickly edit text in a stream, replace a word, change a name, clean output before passing it on. And this is also a very typical Linux style. One small command does one clear task. So, today we covered streams in Linux and understood the difference between normal output and errors. We learned how to redirection, use pipes, and build simple command chains. Then we looked at text filters and learned how to search, sort, count, cut, and replace data in text output. So now you understand much better how to process text in Linux quickly. In the next lesson, we will talk about archives, file search, basic network commands, and simple network diagnostics. See you!